Good morning, sir.
Good morning.
So,
Mhm.
so yesterday I bought the 14th edition of Guiding. One of my friends she gave me. So now I want to start reading. So I'm not able to understand at which chapter is going on. So can you just tell me that what
Yeah,
should I read?
you'll get the answer today.
Okay, sir. So I started with the chapter 1, the functional organization, but that was I thought that it is not relatable to what is going on in the lecture.
True.
Recording in progress.
So just after 1 minute, we'll start. Please stop the recording for.
Recording stopped.
I stopped the recording because there were few things which I never wanted to get recorded. The questions. I mean, some of the questions. See, it's like if I'm friendly to that doesn't mean that such questions should come. Yes, I got Manthan, I got your message. The questions which were asked is that you have got so much of money, so you please adopt. Then second email was how much you earn per month. There was one more email, how much you earn per year. Then one more email was, do you have property in Mumbai? No, right? So I haven't replied to all of them, but this is like, that was a bit strange. I was not expecting such. And then that email was so long that please adopt me. Now I should ask that person that for me everyone is same. So why are you so special? So that I should adopt you. So the genuine questions. One which was about the procrastination. Procrastination. I'm not taking the name, but yes, I saw your email that you said, I don't know how, but I can't seem to leave my procrastination habit. I sit for 2 to 3 hours continuously just scrolling down, we'll need some help. This is not me. This happens. It is like all of you are fighter pilots. In fact, all of you are like fighter planes. But this fighter plane is of no use if there is no set target. Right? It might be the finest of the stealth bomber plane. But if the target is not set, so in that case, you will keep on moving in one direction to another direction without achieving anything. The easiest method to stop this procrastination is every morning, before you go to sleep, before sleep, just write 2 things. I'll give that. Just let me finish this part. So before you go to sleep, just write 2 things which you'll be completing next day. Not more. You can very well write that I'll drink 3 liters of water tomorrow. Happy, no problem. I'll read 5 pages in entire day. No problem. Right? Let it be simple. Let it be manageable, but do it. So when you do this thing, it would happen like next day morning. It is like next day you'll be able to complete this thing in any case, right? Very easily. But at least it will release happy hormones in your brain. And another thing what happens is that you'll be having self-faith that yes, I can achieve it. I can do it. This would be day one. On day two, you won't feel like that putting such simple things. You'll say, today I'll read 10 pages a day. Right? Or you will say that, say, suppose this is just the example, what I do. Say, I'll say that I'll pay all the bills, all the pending bills. So it is completed on that. Now, merge the technology with it. Say, for example, we have got Alexa, right? Amazon. So you just give the command that on every 15th, remind me to pay all the bills. The moment you wake up in the morning, right, it would say, no problem. For those, all the friends for whom it is your first lecture, don't worry. Just a minute and you'll be able to understand it. These are the emails. These are the answers for all these emails which are received. So it could be Alexa, it could be your Siri. Right? You can set such commands that so that you definitely complete it. Then to-do list that can also be prepared. But the whole idea is don't make a very lengthy list that I'll do 5 things and 10 things and 20 things. No. If you are setting up for the exercise, then don't set the thing like that I'll do exercise for one hour. Right? Set it for 10 minutes. And that also 10 minutes in the entire day. Right? Anytime, entire day. And even in breaks, it would be okay. So 3 minute, 4 minute, 3 minute, even that is fine. But your brain should be habituated for this success. Because every time you will complete these 10 pages, right, your brain will get a reward. You feel good. Yes, done. Keep doing this thing for 1 week. For 1 week, there should not be even a single event on which you failed. And then you'll find that next week will be a total life-changing week. This procrastination part, right, where you are delaying the things, that will be totally eliminated. And continue with this habit. So keep a diary. Keep a diary in which you keep on writing everything. Anything which is documented, right? Remember, anything which is documented, it always serves the purpose. If you say that, yes, it is in my mind, it is of no use. Write it down. Write it down. When you write it down, people say weight loss is very difficult. Weight loss is very easy. Write down. For the weight loss, write down even if you eat 1/4 of sandwich, write it down. At what time? Write it down. As you will write at the end of the day, when you see, you'll find that at, say for example, 1 o'clock, at 1 p.m., I had a fine lunch. Then what was the need to PM, whatever you eat, it is a sort of emotional eating. So all such things, when you document, when they come in front of you, you'll find it, yes, this is the point where it can be eliminated because it is like a report card. Okay. Achha. Yes, we'll talk about this fitness part, weight gain, weight loss, all these things we'll talk about it. Yeah, email ID just take this. It is TILLURMBBS. For those, I'll quickly finish all the questions and then we start with our next topic. Yeah. So this is the email. On this email, just you can send your queries. Right? Today is the first lecture, so welcome Snehal. Welcome everyone for those. Today is the first lecture. We'll be starting with the topic of physiology. All the topics of physiology whatsoever we'll be discussing for the next, maybe this entire month, all those topics, they will be a sort of independent topics. So even if you have missed anything from the previous topic, from the previous lecture, not to worry. Focus on this lecture, learn this piece of physiology, and that would be useful until the next lecture. Using 12th edition of Guyton Hall, it is totally fine. Totally fine. The link has already been shared, Varun. It has already been shared and all the files, they are lying over there. Weight gain occur due to lack of sleep. Definitely it can occur due to lack of sleep. Because say lack of sleep, you don't sleep. When you don't sleep, so then these are the extras. When you are awake, you feel like eating something, and say that emotional eating, it comes into the picture and you keep on eating. Second, when your body is not taking enough rest, so many of the metabolic processes, they are badly disturbed. So yes, enough sleep is needed. It is not the quantity of sleep, it is the quality of sleep. Right? Quality of sleep, that is very vital. Total BDC, BD Chorasate, has got 4 volumes. That is a book for anatomy. All right. So let's start with our stop. All the emails received just now will, no problem, Varun. I'll share the link. Don't worry. At the end of our today's session, right, I'll share the link. No problems. Or you can just send a mail to me. You can send a mail to me.
So,
Whilst they are because of hormonal imbalances. That's a very common cause. So just keeping the face clean and keep washing it, keep it dry. That would be the best thing. Unless it is extremely high, then you have to start the medicine like tetracycline or any of the antibiotics. But otherwise, it is not recommended to start those antibiotics. Things will be resolved by itself. So keep patience. Right? Steam is very effective, especially if there are recurring boils. Steam, right? That would be very effective. Yes. For asking something?
Yes, sir.
Go ahead.
Sir, every lecture notes we have to note down and book, right?
See, notes, if you are writing, then it is good for you. Otherwise, these things will be shared. They are at that common link. Right? So these notes will be placed over there. And today you will see that if you follow these notes, every topic, every detail, right, whatsoever is needed, it will be mentioned. It will be clearly mentioned. Yes, you can add some extra points for your understanding, but otherwise everything would be here. Right? And do remind me that we'll be revising it also at the end of our today's session. And that is the exact way, the way you have to revise. Still, if there is any doubt, just let me. Let's start with our today's topic. Okay, so our today's topic is sodium, potassium, ATPase pump. Sodium, potassium.
Recording in progress.
So all the questions now we'll be discussing at the end. Right? Let's start with the topic. So topic is sodium, potassium, ATPase pump. This is one of the very vital topics. Now when we say sodium, potassium, ATPase pump. So this tells us multiple things. One, anything which is ending with ase, that means it is using the enzyme. This would be an active pump. Active pump, that means it will be requiring some energy. This is pump, that means it is pushing and pulling something, and that is the sodium and the potassium. This pump works 24/7 without any halt from our first breath to last breath, right, for the entire life. This pump works on every cell, right? On every cell surface. That is, in our body, there are trillions of cells, and this pump works on all of them. If this pump stops, gone, right? Game over. So this is the importance of this pump. What this pump really does is that whenever the action is taken, right, there would be major changes. There would be wait. Now all the questions at time. So whenever we talk about this pump, right, as this pump is moving, so this is the cell, and this is the cell, and in cell outside there is so much of sodium, right, sodium everywhere, and inside it is the potassium. Right? Inside is the potassium. This is the normal environment. But whenever there will be action potential means when the current comes, muscle contracts, heart beats, right? Any of those things when it occurs, there would be transfer of these ions. It is the sodium potassium pump which comes into picture, and it resets the system so that cell is ready for the next action. Simple as that. So if we consider that here is our pump, this is the pump which is sitting on the cell surface. What it will really be doing is it will pick up sodium from inside and will push it outside, and from outside it will take the potassium in. How many? 3 sodiums against 2 potassium. Right? So 3 sodiums will be out, and 2 sodiums, 2 potassium they will be coming in. In this process, it has to use the currency of the body. In body, rupee, dollar, nothing works. It is the ATP. Right? It is the ATP. So it is the adenosine triphosphate. This ATP, we can say it is the currency. It is the energy currency of the body. So that is what is utilized. So from this much discussion, at least this much is clear that this particular pump, which is located on the cell surface, it is passing through and through the membrane. So that's why we can say that this is a transmembrane, right? It is passing through the membrane. Right? All these pumps, they are as such nothing, they are all made up of proteins. So that's why we say that this is a transmembrane protein. We'll be going in depth about this protein. Right? At the same time, this will be a transport protein. Transport means it is carrying something and putting it on the opposite side. So we say that this is extracellular fluid, and this one is the intracellular fluid. Right? Intracellular within the cell, extracellular outside the cell. So transport protein. This transport protein is used to transport the things from one point to another point. And in this process, this is not happening for free, right? It uses energy. In our body, there would be certain actions which are not using any calorie, which are not using any of the energy. So, example, the biggest example, what you are doing every time, right? And that is you breathe in and then you breathe out, right? The normal breathe out, no, that is the forced expiration. But the normal inspiration, energy is utilized, but the normal expiration, in which gradually your diaphragm goes up and the air which is into the lungs goes out, because lungs are very much interested in collapsing. So they collapse gently and the air goes out. This is a normal, quiet breathing. So normal, quiet breathing, the energy is utilized only when you take the breathe in, but no energy is utilized. It is totally free, right? Not a single molecule of the energy is utilized and it goes out. Regarding how ATP gives energy, ATP, it is the adenosine, right? Adenosine phosphate And you must have heard of adenosine monophosphate, adenosine diphosphate, and adenosine triphosphate, what is called as the AMP, ADP, and ATP, right? This you must have seen even in your. Right? So transport protein uses energy. That's right, transport protein uses energy. Exactly. So these are the molecules. So ATP, adenosine triphosphate, how it happens like that? See, in the adenosine monophosphate, there is one phosphate, right? One phosphate component. Then in di, two phosphates. In tri, three phosphates. These phosphates, right? These phosphates, they are something which will be giving energy. So when you break this, ATP is broken into ADP plus phosphate. This thing is picked up by our pump and it will work. So it will be releasing ADP and this phosphate it is utilized. Once the work is complete and then new phosphate comes, so once again the new ATP is generated. So you can consider the ATP metabolism itself is a long topic, it's a separate topic, but in nutshell I'm trying to explain so that you understand what would happen in the cell. Even if there is any confusion, I'll clear it as we proceed. But one thing is clear, that this is the protein which is through and through the membrane, and this membrane is the cell membrane. And in cell membrane, as last time we discussed, it is made up of phospholipid layer, right? Bilayer, phospholipid layer. So this is the point when these pumps, they are stationed and they keep on working. So by the end of say 2 weeks, you will find that the cell surface is as such, it is not like this. It is like our borders. It is a pretty busy area, right? There would be some aquaporine channels, right? There will be 7-pass receptors. There will be 1-pass receptor. There would be these sodium potassium pumps which are going, right? So many things. And on top of it, it is the sliding mechanism, right? Everything is happening, everything is moving. Right? So that's why it's a very busy area. So today we'll be focusing on sodium potassium pumps, right? So as in our subsequent sessions, we'll be discussing about all these things in complete full depth. Because say in case if there is any disease, then that disease which is occurring into the cell, we give some medicine to the patient. So that medicine should really enter into the cell and should kill those villains, right? Those who are trying to, say, disturb our physiology. So this is the reason why we need to, say, do a very proper survey when the mission is set. Same purpose. So what would be our topics for next for this entire month? By the end of this month, we'll be knowing ins and outs of all the details of the cell, how they function, whether it is a respiratory cell, whether it is a cardiac cell, whether it is a muscle cell, whether it is the neuromuscular junction. We'll be knowing in depth about the mechanism of action, factors which are affecting all of them, and in which case it is disturbed, along with many of the diseases. So it would be a combination of not only physiology, it would be a combination of physiology. We'll be learning some pathology, we'll be learning some pharmacology, and yes, part of medicine also. Now medicine is part of final year, pharmacology, pathology part of second year. Instead of thinking like that we are learning, say, physiology, what my perspective is, you learn the whole thing as a subject. We learn the whole thing as a subject, as a topic. That by the end of session, that topic should be crystal clear to us. Right? This is the reason that once our general physiology is complete, we'll be starting with very easy, very comfortable, and very happy cardiac physiology. Right? Cardiac physiology. Normally, it is said that yes, this is very complex. No worries. We'll be starting it in such a simple way, and gradually we'll keep on mounting till by the end of when we'll say, okay, today we are completing cardiac physiology, you'll be knowing about the coronary angiography, you'll be knowing about myocardial infarction, that is how the heart attacks come. You'll be knowing about how to treat them, how to handle them. You'll be knowing about the ECG, diagnosis, right? You'll be knowing about the Doppler, you'll be knowing about CT, MRI, right? How the images they occur, what are the types. You'll be knowing about congenital heart diseases, that what happens when the kid is born and in case if that kid is having any problem. So all those things, right, they will be discussed. So that's how you'll be knowing it at length. So this is the purpose. So I'll keep on telling you that what to read from the guidance, but yes, this would be like a combination. The things would be integrated from several books. Okay, just a minute. I feel like that, let's give liberty to everyone. And they don't even understand. This money, should I remove this person? Let me remove. Just a minute. Yes, I removed him. No, I don't feel like doing it. Sorry, but I have right now muted everyone. Okay, so just so that no one is disturbed. Let me know. I'll unmute. So right, this would be our target. So let's start with sodium potassium, and we say that this is a pump. This is a pump which will be resetting the system. Right? It is a transmembrane protein, transport protein, and it would use energy. And that energy, how? ATP, right? Adenosine triphosphate would be used. And this adenosine triphosphate would be broken into ATP plus this phosphate. And this is the inorganic phosphorus which will be picked up by the pump. Now, during this, the enzyme which will be used would be ATPase. So this one would be our enzyme, right? So that would be the enzyme which will be used. Now these electrolytes, they are extremely sensitive. So if the electrolytes they are either decreased or increased, right? So they will play a major role, especially the heart, especially the neural system. They will be involved extensively. So you must have noticed that when the patients are admitted, they definitely measure sodium and potassium. These two things they are definitely measured. So roughly about say 138 to 140. This range, right, milliequivalent per liter, this is a very tight range. It's not so that the big variations are allowed. No, this is a very tight range. If it becomes 130, yes, you need to work on it. Similarly, potassium is still more dangerous. They will be playing. Now, this potassium is less outside, it is more inside the cell. So that's why outside the cell, it is very narrow range. It is in the range of about 3 to 5, right? Roughly 3 to 5 milliequivalent per liter. It is into that tight range. If it drops below 2.5, then this is hypokalemia. If it goes beyond 6, then it is called as a hyperkalemia. And when either hypo or hyper it happens, it will be affecting the heart. Heart starts developing what's called as normally if the heart is beating nicely, then it is called as the rhythm, right? When it is not beating normally, right, it is called as arrhythm. Arrhythm is abnormal rhythm. And there are several abnormal rhythms. Yeah, we'll also be learning the auscultation, right? What we hear with our stuff. So yes, we'll be learning that also. So that is the arrhythmia. Right? We don't want to develop any of these things, so that's why these are kept in a very tight range. Now comes that, say, a patient comes, right? And that patient has, let's say he was driving, right? Hyper or hypo. Yeah, I'll write down. Right? It is hyper or hypo. When we are dealing with potassium, it is called as the kalemia, right? We used to remember it like kalemia. Either way, so hyper or hypokalemia. And for the sodium, it would be natremia. Hyper or hypo. The example. Someone is driving and then suddenly there is a accident, right? Head-on collision. So that would lead to lots of crush injuries, right? Crush injuries. When these are crush injuries, that means cells will break. When cells will break, right? Now take like this. When this cell would break, right? So what would happen to its potassium? That potassium that will be released extracellularly. So that potassium will come into ECF. Right? So thus, whenever there is any accident, major injury, major it is called as the crush injury. Because in crush injuries, even they are bad. Right? Crush injury. Because it grinds, it crushes many of the cells, and those potassium they come out. Say when there is a cut, right? So it is relatively less when there is a sharp cut. Right? So that is a crush injury. Well. Just give me. So the crush injuries, they will be leading to hyperkalemia. So because ECF has come out, so in ECF the potassium has come out. Now see the condition. Already there is accident, and then how bad would it be if patient dies of cardiac arrhythmias? How dangerous would it be? Right? That would be very bad. Crush injury means when there is impact. Say for example, say if the hand goes into machine, right? So how much injury would be there, right? Everything would, all the tissues will be crushed. When there is vehicular accident, you'll find that yes, from the shoulder, if the car wheel has gone, so entire shoulder, so many big muscles, right? They are badly damaged. So much massive tissue destruction. If there is a cut, right? So in that case, the tissue destruction is minimal. And though there would be bleeding, but the tissue destruction would be less. Say if there is this hand and if it is cut, so yes, that much injury is there. But when it is a crush injury, then the amount of tissues which are destroyed, they are very high. They are extremely high. So you need to take care of this part. That whenever there is crush injury, whenever there is tissue destruction, tissue damage, there would be hyperkalemia. And when there is hyperkalemia, that is leading to what? That is leading to cardiac arrhythmias, right? Increase potassium. So right now, just keep this much in mind. Right? We'll be dealing with more in detail, absolutely in detail about all this. So here are some of the conditions. Right? One, which is the crush injuries, especially the vehicular accidents. Motor vehicle accident, right? MVA stands for motor vehicle accident. Then burns, because in burns, suddenly the large amount of tissues they get destroyed. Then when there is massive infection is what? Infection is nothing but when those bacteria, right? Those bacteria, they enter into the system and they are fighting and they are killing our tissues. So that is the massive infection. And when the blood cells break, which is what is called as the hemolysis. Hemolysis. When the blood cells, RBCs, they start breaking. So they are also cell, RBC is also a cell. Now there are some conditions which are called as the hemolytic condition. In that, the normal lifespan of this RBC is about 120 days. In those conditions, these cells, their life is so less, right? So they start breaking more and more and more. So they'll keep on releasing potassium. That will affect the heart. Right? This is clear? So all these conditions, right? So when we'll be discussing crush injuries in surgery, when we'll be discussing how to manage the burns, so that is from the percentage we have to figure out massive infection. Right? So that is also we'll be studying, especially in pharmacology when we're talking about the antibiotics. Yeah, in every situation, if there is hyperkalemia, there will be cardiac arrhythmia. Yes, that's right. That's right. Below crush injury, MVA stands for motor vehicle accident. Right? Motor vehicle accident. So if the potassium is more, yes, heart would be affected. So these are the conditions which will lead to increase potassium. That is the hyperkalemia. Right? These are the basic conditions. Let's move on to now our pump. As we said that this is our sodium, potassium, ATPase pump. Right? So first, let's see that how this pump is. That word from B, which one? Burns. This one. This is burns. Right? Burns. Jal jate hain na, burns. Now that could be a chemical burn or it is a fire or anything, but burns. So this sodium potassium pump, it is made up of proteins. Right? We talked about it, that it is made up of protein. So there are two major types of proteins. One is called as the alpha protein and second is called as the beta protein. Alpha is bigger, right? This is a big molecular weight. It's a big molecular weight protein. And it is this alpha protein which will be taking all the responsibility of all those transfers. Right? So this is the person who will be in action. So then what about the beta? This beta protein is a small molecular weight. Right? It's a small molecular weight. So what it really does is, this particular protein, it is used for what's called as anchoring. It grips. So here it is, right? As in ocean, right, you'll find that there is a big ship, right? The big ships. But all these big ships, they work, but then there is one, what is called as the anchor, right? So once this anchor is laid, right, once this anchor is laid, that ship will remain stable and then it can do the operations. This is true for every ship, right, irrespective of what type of. So if the ship is very big, there will be multiple anchors. But those anchors, they will be falling and they'll be holding the ship at one position, exactly the same function. This small molecular weight, its function is only one, and that is anchoring. Anchoring. Because this is a very dynamic pump, right? That pump is working fast. So this works that way. Okay, it will hold that pump at one particular place, and then it will securely start. Second, I'm just keeping a space blank. I'll fill this space after a few minutes. Right? First, we just understand this alpha. We talked about GPCR, G protein coupled receptor, in which was also called as the 7-pass receptor. Right? Going back, say this is our cell. So there was 1, 2, 3, 4, 5, 6, 7. Right? So this is This was the receptor which we discussed last time, right? The 7-pass receptor. Whenever we write like this, that means just understand it is a receptor. It is a receptor. This would be our universal language, because these receptors, they will be coming not less than 2000 times. So every time whenever we'll write like this, it would be the receptor. So you can also cultivate that habit. Why to write RECEPAT? Just this much, 7-pass receptor. It is also called as the GPCR, G protein coupled receptor. This was another name, G protein coupled receptor. G stands for guanosine. Guanosine is a type of protein. There was one more name, and that was the transmembrane protein, right? Because this is going across the membrane. It was the integrated protein. Integrated protein means we cannot peel it out. कि चलो उसमें से मतलब उखाड़ के निकाल दिया protein. You can't peel it, right? If you try to take this protein out, you will be destroying the cell membrane completely. So that's why all these are, that is the integrated protein, correct? Integrated. Then it was transmembrane, right? Transmembrane. It was also called as a serpentine protein. See, all these serpentine protein or the serpentine receptor. But what they were doing, mark one difference between this and what we are discussing today. This one end was in ECF and this other end was in ICF, correct? So when we do 7-pass, so 1, 2, 3, 4, 5, 6, that the 7th one has to come inside. So one end is outside, one end is inside. So that this portion where any of the ligand, what was ligand? Ligand was that any chemical, any hormone, any drug, anything is coming and stimulating the outside. Wait, this person has come again. Say, just a question to everyone. Will it be fine that from next time onwards, I make the rules bit strict, like that you have to authenticate yourself, after that only you can join the meeting? Should we do that? Because in that case, I'll be having a very perfect control over about all these nonsense, what that guy is doing. Yes. So everyone has said yes. Not a single no is there. Great. Thank you. Bas, I just want. Serpentine protein. I'll just explain. I'll explain everything. I'll explain everything, how to authenticate. All you need to do is you have to just say, now it will happen like I'll be creating a new meeting ID, right? You will be and say when you connect, right? You have to just give your email address and then you have to create an account in the Zoom. It is free, right? It would be totally free. Right? You don't have to spend anything. Okay. But just you have to log in. That's right. You have to just log in. Okay, chalo. Coming back to this, serpentine means like a snake. Serpentine means it is like a snake. Like a snake, right? It looks like a snake. So that is what is called as the serpentine protein or the serpentine receptor. This is what was happening, that there was a ligand. Ligand means something which is stimulating from outside and its effect is coming inside. So that was the 7-pass receptor. But over here, for our protein, when we are talking about alpha, right, this alpha is a 10-pass receptor. It is a 10-pass protein. 10-pass protein. Now see the fun. It is 10. 10 is an even number. So from wherever, let's say this is the cell membrane. We start from here. So see, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. See, it started from inside, it is ending at inside. So this is the difference. Whenever the numbers would be odd numbers, that means one end would be outside, one end would be inside. So they will be like a typical receptors. When the numbers are even, right? So they will be like pumps, because it is like pump. It has to be triggered from inside, and then it will take something from inside to outside, and then it will take something from outside to inside, right? It is like a pump. It will just move the things. So when the number is even, right, things are starting inside, ending at inside. That means they are like pump. And when the numbers are odd, so that means they are like receptors, right? That means something would be stimulated outside and its effect will be seen inside. Okay? No, it won't be explained like this in any of the book. Right? So right now, don't worry about any of the book. Just understand. Achha. So this is big molecule, 10 pass protein, right? 10 pass protein, and this one. So we said now that this beta will do what? Beta will go for anchoring, and what beta does, the second thing, that is the so fantastic, and that is folding of alpha. Folding of alpha, that is done by this folding, that 10 pass, that folding, that thing is done by beta. So beta does two important things. One, the anchoring, and second, the folding of alpha. Right? And then the alpha is now happy, alpha is ready, and this alpha will be taking the action for the transport of sodium and potassium. So now our next target is, let's understand how they work. Correct? So fresh, now comes our alpha protein. Right? Beta has done its work. Beta said that, all right, alpha boss, you start working, and I am anchoring. Right? I am anchoring. I am just putting the anchors, right, so that our entire system is stable, and then the folding of alpha. Done. Now the alpha protein is coming to picture. So as it goes, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the cell membrane. Over here, on both these ends, right? These are like switches, right? They will be like switches. On one side there is an amino group, and second side this is carboxyl group. So you can just consider that these are the switches which can trigger on, can trigger off this particular pump, whether pump should work or not. Right? Pump should work. Pump is supposed to work for day, night. Day, night it would be working, but still there are few controls, because these pumps, they are controlled very delicately. So we'll see that. So here is the alpha protein. First thing what it is doing. This is, as we said, that this is the active transporter. So active transporter means, now for the next 5 minutes, even if there is smallest doubt, please ask immediately, right? Because considering this as the foundation, next time we'll be learning about the resting membrane potential, action potentials, all those topics are going to come. So active transporter means when we are inside, right? Forget about all the ions right now. This is sodium. Sodium is inside, and 3 sodiums, they will be pushed outside. But outside, so there are large number of sodiums, right? There is no kami, there is no deficit of sodiums outside. But against that, you have to push these 3 sodiums. That is what is called as the against concentration. This happens in just in a neuron or every cell. every cell of the body. These pumps, they are working in every cells of the body. That's why in the initial stage, we understood the concept of that these are the cells and this is the ECF and this is the ICF, intracellular fluid and the extracellular fluid. So when we say that ECF, extracellular fluid, is having sodium, so now just consider all these green dots, they are sodium. So there would be sodium, right? These are all sodiums, right? These are all sodiums, right? There is so much of sodium. And how do we remember it? We said ECF is external. External is samudra. Samudra means pani is salty, sodium chloride, right? So that's why in ECF there is large amount of sodium, there is large amount of chloride, right? But right now we are focusing on sodium. Against this sodium, right? When same sodium is to be pushed into the sodium, so there would be so much of resistance. But this pump is so powerful that it pushes this sodium. Because outside it is 140 milliequivalent per liter. This much of sodium is present, and still we are pushing it from the pump outside, right? So mehnat lagti hai na. This is like where this pump has to work. That's why this is called as the active pump. It is called as the active pump. It has to work, right? So this is one. Sodium already present, because what body would try to do? Body would try to neutralize the thing, right? So it is like against gradient when you have to push, so then that requires the effort. So that's why it is called as the active transporter, because it is transporting against the concentration of sodium. Sodium is present, right? Right now, don't worry about the potassium, because potassium is also working in the same. Only the direction would change. The second, here is a cell. Sodium is what? Positively charged. Correct. Sodium is positively charged. Over here, there are sodium everywhere. So these are positive. Right? All are positive. Against that, you are pushing 3 positives. Right? Already so many positives. And against that, you are trying to push positive. So this is what is called as the electric gradient. One, which was the substance gradient, ion gradient. Sodium was present, and against that you are pushing sodium. In this case, they are already positive. Against that you are positive, because positive would repel, right? Positive would repel. This 140, this is the sodium level, serum sodium level. So in the laboratories, in the lab, when you take the blood and then when you check it, and then when the report comes, so in that report, this 140 milliequivalent per liter, that is the value. If it is less, it is alarming. The way we talked about that in potassium, it is 4. So if it comes to 6, it comes to 8, it comes to 9, then first thing which you take care is decrease the potassium first, because take the ECG and you'll be able to see the changes in the ECG. That's what I really want to emphasize on. That when we'll be learning the cardiac physiology, as I'll say that this is how, so this is the potassium level, and in this potassium level is, let's say, 8.9. That is hyperkalemia. So then see the ECG, how it really happens. And as this potassium level drops, see the ECG coming back to the normal pattern. Right? This is what we understand, so that we integrate everything. And how the patient would be responding. Well, for that we need to understand that what would happen to muscles, what would happen to nerves, right? Because this potassium will be playing a role into the action potential of nerves, action potential of muscles, action potential of cardiac muscles, everywhere, right? So that's the reason I said that for next 2 weeks, even if you don't read from any book, just focus. That would be making a very solid concept. What exactly you didn't understand, right? Be specific. We can't repeat the whole thing. Na? Just be specific. I don't mind repeating, but please be specific. Because I'm trying to make it as simple as possible. So more than this, it cannot be simplified. And regarding this 140, even if you don't remember it right now, chalega. Potassium, just potassium, is that when we say potassium is so important, right? Potassium is so important because it can lead to cardiac problem. But right now we are talking about a sodium. Sodium drops down. No, sodium is what is happening is in this case that we are pushing the sodium out of the cell, right? So that's right. Shweta. This second, this is what is called as the against electric gradient or FET, right? Against electric gradient. Right? So when I say take one, that means this you have understood. We are trying to throw sodium where there are large amounts, right? If there is a room in which there are 10 people and outside if there are 1,000 people, you open the door. So those people, they will try to come in. And then when you have to push these 3 people into that crowd, so you have to make a very extra effort, right? You have to make that extra effort to just push them out. So that is one. Here, electric gradient, right? So many positive charges, they are outside, right? And then you want to push another 3 positive, that they repel, right? They won't allow these to enter. So how strong you must be so that you are pushing not 1, not 2, but 3 positive where there are thousands of positives, and against that you just push them, right? So removal of sodium from the cell against the concentration. That is the active transport. That's right. And this one is called as the electric gradient. So that's why this pump is also called as the electrogenic pump, right? The other name of this pump is the electrogenic pump. Right? So this is good, electrogenic pump. Now we move on to the third concept. And still, if you really want to go into still depth, right, there is one more super interesting thing. You have to visualize a bit, but yeah, chalo karte hain. 3 sodium, right? So forget 3 plus are there. When these 3 plus, they will go outside, what would happen to this cell? That cell will be relatively negative. Getting it? Because see, this cell will be losing 3 positives, right? So this cell will be negative, right? Because the positive is leading. So now it happens like this internal negative environment will say, "Kya positive kahan bhag raha hai? Aaja, right? So it will in fact pull these negative ions. They will in fact pull this positive because negative, positive, they attract each other. So it would say, no, don't go, yaar, right? So they will pull. So against that, our pump has to be so powerful that this internal environment is pulling inside, right? And the external positive is not allowing to come, but still our brave pump is pushing these 3 positives outside, right? So that's why this is considered as a very powerful electrogenic pump. And this works day, night, non-stop. Third important thing is, we'll see it in process, that our pump, it uses energy directly. Now, what is this directly? Directly. Directly means it is like cook yourself, eat yourself. So our pump is capable enough because it has got ATPase. It will say, I have got the enzyme, right? I got the enzyme ATP. So that ATPase will do, ATPase will attack on ATP, will break it into ADP, adenosine diphosphate, and here is my food is ready, energy is ready. Use it and start working. So this pump is not dependent on anyone. Someone will break and then our food will come and then we'll start working. No, this pump tells I don't need anyone. This is ATPase. I have got my own ATPase. This will fire, this will break ATP, and food would be ready. That's why this pump is called as a direct pump. Right? Another name of direct pump is primary pump. Primary pump. All these things, these are the concepts. Right? Any doubt, let me. But these concepts, they are the concepts which are the hardcore concepts for many of the pathologies. Because at that point, we were just discussing that, okay, this is the electrogenic pump and it is a primary electrogenic pump. Instantly, it will be clear, yes, it is using the ATPase, it is using the energy by itself, and this is what it is doing, it is working against the gradient. When we say this would be a passive pump means no energy is needed. Right? No energy is needed. It is working by itself, right? So yes, there would be few pumps like that also. Right? Next is, it is not so that body has got only one type of this ATP only. There are even other methods also. Potassium will come. Just hang on for a few minutes. There would be a process of what is called as the phosphorylation. Right? It is called as the phosphorylation. This word, right, keep cemented into your brain. This particular word will not come once, twice, but it will come million times. In every process, right, there would be phosphorylation. So it uses ATP directly, therefore it is called primary. Yeah, it breaks the ATP by ATPase, and ATPase, it is like home production, right? It is not going somewhere else. ATPase, they do not. No, it is pump is telling I am having ATPase, right? I break. So yes, that's why it is called as the primary. That's right. So phosphorylation is what? ATPase is broken. ATPase is broken by the ATPase, and this is the ADP which is released, right? And this phosphate, this is picked up. This phosphate would bind to alpha. So this phosphate, right? This phosphate is a very miracle thing. It is like a loaded with energy, right? So with whosoever it is attached, so it is called as the phosphorylation, the both process of phosphorylation. Phosphorylation means that this phosphate, right, it is now connected to someone from us. So over here, it is connected to, now it is binding to alpha protein. So that will say that our alpha protein is phosphorylation. मतलब alpha protein को मजा आ गया. That alpha protein is happy, right? Alpha protein is now active. So that is what is called. This process is called as the binding of this released phosphate with alpha protein is called as the process of phosphorylation. Right? So phosphorylation of alpha protein. Now this process, this occurs at 1,000 other places, but the common name will be phosphorylation. Whenever the word phosphorylation comes, understand one, the process has started, it is active, and with whomsoever it is attached, right, it is now going to work. If it will be muscle, so then muscle is now going to contract. Muscle is happy that now I have to work. Right? If it is heart, so heart would say now I have to beat. Right? If it is respiratory system, so yes, they'll say, chalo, let's start the transfer of oxygen, carbon dioxide. So phosphorylation is that process which is like a switch, right? Which is like an ignition. Otherwise, alpha protein pada hua hai aaram se, right? It is sleeping, right? It is not doing anything. So many sodiums are moving, but alpha is telling that forget, right? I'll not work, right? So this is what is happening. Clear? Phosphorylation means becoming active. So here is the alpha protein, and that's why whenever the phosphorylation comes, so this will be telling phosphorylation type pump, or it is also called as the P-type pump. Right? It is the P-type pump. Right? Clear? Yeah. Don't worry. Just for today, I'll do that. There are some third grade persons every time. कहीं ना कहीं से आ ही जाते. Such sadist people. That's what I'm doing. But every time he's using different ID. I'm removing him every time. But next time I'll just make it that no one can change the name, and once blocked, that's what I'm telling you. Once blocked, so they should not be able to join. And we'll do also one more thing. We can put a restriction like that. Let's say we all of us are meeting at 10:30, right? We'll close at 10:35, right? So after 10:35, no one would be able to join. And so once anyone is removed from the meeting, gone for at least that session, because such persons, they'll keep on coming. I think this is fine because all of you are pretty punctual. But really sorry if anyone comes at 10:36, that he or she won't be able to join. If someone is having that network issue or if someone is getting disconnected, yes. Koi baat nahi, chalo, we'll handle. No problem. Yes, you are 100% right. If there is network issue or disconnected unnecessarily. Yes. I got it. Got it. Stop writing. I got it. अच्छा. हम देखो लिंक टूट जाता. तो से एक काम करना ना. I'll send the message to you. Few of the people there, those whose email addresses are with me. So if you don't mind, today evening or we just do a test run, right, for this proper setup. Can we? Right? Just 5-7 students, if you can come. That would be nice. Chalo. So phosphorylation, ATP, ADP plus. So this is a P-type pump. Okay. This would be like our summary, and then we'll start the action. So this alpha protein is, it will be having what? Summary of alpha protein. Its molecular weight, that would be 1 lakh, right? That high. It's a 10 pass protein. 10 pass protein. Right? Then, because it will be transferring sodium, yes, I got your message. I got your message. That's okay. No need to be sorry. That's okay. My intention is to be one. Right? None of our genuinely जो पढ़ते हैं ना, none of the students should be taking this stuff. I don't have grudges for anyone. ऐसा कुछ बोल दिया, लिख दिया, कुछ हो गया, right? माफ यार, कुछ नहीं, कुछ कोई प्रॉब्लम. Even to the person, right? जिसने मेल लिखी, आपने कितना लंबा मेल लिखा, मुझे वापस दिया, just see that. It's okay यार, relax, कोई टेंशन नहीं, कोई टेंशन. It's okay. No need to be that much sorry. चलेगा. चलो, coming back to this. Sodium binding site. Sodium binding site, because then and then it will bind the sodium and will transfer. But it is also doing the potassium binding site. So there will be potassium binding site. Right? Now this tells us that how complex this whole alpha protein is going to be. Then it is already carrying the ATP in its pocket. So the moment it said, "Chalo, now काम करना है," तो ATP is fired, right? And then, so it has got the ATPase binding site where the ATPase is connected, right? It is like a pocket in which it is keeping the ATPase. चलो इसको use करेंगे, right? Then what next? ATPase binding site, where will it act? It will tell ATP aja, right? My ATPase will work on. So that ATP would come and ATP will burn. So there has to be the ATP binding site. Right? इसके अंदर कुछ भी डाउट हो, but अभी very next will be doing the function of it. So all these things will be clear. So ATP binding site. Then ATP on ATP, ATPase will work. ADP will be formed and the phosphate would be released. ADP, that would be released because ADP, there is nothing like ADP binding site, right? So ADP will never be binding to this alpha protein. But this phosphate, ye to chahiye, right? So that's why there would be the phosphate binding site. Because when this phosphate binding site comes, this phosphate binding this is like rasgulla. When it comes, then person is happy and then the काम शुरू होता है, right? So this is what is needed. So many binding sites and such a protein. That's the reason it is such a large protein. It's such a big protein. And here is continuous. We see that how it really is going to function. So here we start. And for our sake of simplicity, we are making it very simple. Just think it like this. This is the stage 1, and that's our alpha protein, right? And this is the cell membrane. So this one is ECF and this one is ICF. There would be only 2 states, right? So it keeps on moving like this, like that toy, right? It keeps on moving like that. So this is the stage 1. So that is called as the energy state or the E1 state. So in E1 state, it is the inside that it is open on ICF side. Correct? Now this is our alpha, right? We have drawn only alpha. We have not drawn beta. Beta is there, right? Holding it. So that we can think. This is alpha. And this alpha is first what it will do, it will call ATP, right? So here is the hook and the ATP comes over here. ATP comes over. So this is like a hook, right? Langar फेंक के ATP पकड़ा, right? So ATP is. So now the state would be E1 plus ATP. So the ATP is connected to, technically speaking, this would be like ATP binding site, right? This will be ATP binding site. So this is what we are talking about, ATP binding site, right? Done. At the end, everything would be checked, right? Molecular weight is high. 10 pass protein. So see, this is happening like 1, 2, right? So this is happening here and here and here, right? So parallelly, so many things they are working. Arey Mayank, no problem, no problem. You seem to be a very, very genuine person. See, he is such a gentleman. What he wrote is, I would really, no, Mike, I would like to really, you are a very respectable person. Actually, he wrote the message. Actually, sir, the thing is that this meeting link was provided by my friend. And as I was a computer guy, he said me to do the prank. Firstly, I refused, but he sent me 500 rupees. So I thought I'll do it for money. But now I have realized what I was doing. No mind what you wrote. We are proud of you. Right? You are a very honest person. Thank you so much. And take care. But we all of us are happy. Right? No grudges, no hard feelings for you. No problem. So, आप भी सीख लो सोडियम पोटेशियम पंप. So I've given you the email, right? Till yourmbbs@gmail.com. So I'm also, say doctor, but I'm also a computer guy. I'm into networking. So chalo. So right, this is a 10 pass filter, right? 10 pass filter. So this is what is happening. This is what is happening. Correct? So now we know this 10 pass. So that's what is happening. Now, as soon as this second stage comes, there is activation of, say, again, this is like, right, this, and we have got our ATP connected. But this ATP, right, this ATP, as soon as it is over there, it would happen that there are sodium binding sites, right? They are the sodium binding sites. So they will be activated. So these are sodium binding sites. These, right? So activated. So once they are activated, we are into even state. Why we say even? Because still it is open inside, right? Even means, I wrote it, Sanika, I wrote it over here. Even state is what? It is open in intracellular fluid. This is our pump. This pump would be either intracellularly open or it would be open extracellular, right? Either inside or outside. Okay? So that's how it would be open. So here it is. Now it is in even state. Got it? Plus we have got ATP. Plus we have got 3 sodium. So that's the whole package right now. ATP is just attached. Still we have not used its energy, because when we'll use its energy, we'll change the state. Right? That state would be changed, so that will be opening outside. Right? So right now sodiums are loaded. Right? So sodiums, they are loaded at their seats. Now comes the stage 4. So this is stage 1, stage 2. Now comes the stage 3. Right? Stage 3. Now for the stage 3, obviously ATP has to come. Right? ATP has to come. So Here it is. Here it is. And that's the hook where the ATP is there. And then it will open its pocket. And from that it will say ATPase, thak, iske upar maro, right? ATPase will act. All those sodiums now they are well packed, right? They are onto their seats, right? Seat belts ready and ready to fly, right? And this is ECF and this is ICF. So now ATPase, from the ATPase binding site, right? It will release the ATP, right? ATPase. And something happens at this point of time. When this is breaking, this entire thing will change its shape and it will be like this. It will be closed from both the sides. It will be closed from both the sides. So sodiums are here, sodiums are here, sodiums are here. And this ATPase is acting on ATP which was bind with us, right? We broke it into ADP. This ADP is released and this phosphate and that phosphate is picked up, right? Where it will go? This phosphate will go on the phosphate binding site. So we have got the phosphate binding site, right? Looks like stomata. Right? So we utilized ATP binding site where the ATP was connected. Then we used the ATPase binding site, right? And then this phosphate binding site. So that is also taken. So the situation will be this. Stage 2. Where is the confusion? Should not be simple enough. Stage 2 is just ATP is connected and sodium binding sites are open and the sodiums are connected. That is stage 2. From stage 3, it goes into it is called as the occluded state. Occluded state. Because when the ATP action is getting done, high energy action, so it will just close the whole thing, right? So that ions are protected. So ATPase came into picture, acted on ATP, ADP and the phosphate. They are released. So ADP is released and phosphate is picked up. Now the pump is energized, right? So stage 4. So this is the stage 3. So this is the stage 3. The stage 4 would be something like this, right? You'll find that that is perfectly fine, right? The stage 4 would be sodium, sodium, sodium. Now ADP that is released because we don't have any ADP binding site. ADP binding site. We don't have ADP binding site. So we don't bind ADP. ADP goes. But here comes this phosphate. And now we are called as energized. Right? We are energized. So this is called as the phosphorylated pump. Phosphorylated pump. Right. So this is active pump now. Now it is sorry. Now it is active. When this thing occurs, this energized state is now called as the E2 because it is now about to open outside. It is having what? 3 sodium plus phosphate. Right? So phosphate. Pump is energized, phosphorylated, ADP is released. And the next stage, as you must have guessed, and that is Its pump opens. This pump opens, so the sodium released. These sodiums are released. Over here, it is still connected, but it is still giving power. So now into the E2 state, we are into the E2 state. We do have this inorganic phosphorus, but minus sodium. Because it has opened outside, fluid is released. The moment this thing occurs, the next stage starts. This is the stage number 6. Now blank spaces for sodium, right? No one will come there. But as soon as the sodium is released, the new spaces they open up. And that is for the potassium. So from the ECF, potassiums they come and they take their seat. This is ECF, this is ICF. So over here, the stage would be that we are into the E2 plus this is Pi plus there is 2 potassium. Right? So that is the stage 6. Stage 6, return journey starts. Stage 7. So in stage 7, once again, as soon as the potassium comes, it comes into the occluded state. But this time, K plus, we have got the potassium. So it would be E2 plus Pi plus 2K plus state occluded. State occluded. This is still giving power, right? This is still giving power. Stage 8. Released, right? So this is released. As soon as it's released, this pump's capability to go into the occluded state that opens. This is like initial position. So this is lost. So if we were telling that when it comes, it was phosphorylation, now it's called as the dephosphorylation. Dephosphorylation. Correct? And when the dephosphorylation comes, it opens into the original state. Right? So now here is the potassium, here is the potassium. Right? They are there. And the situation would be we are into the state of now from E2 we are into the back into the E1 state. Correct? Plus we are having 2 potassium. And we don't have any phosphate. Right? That's why dephosphorylation. And then comes the 9th stage. The 9th stage is this, and this potassium, they are released. That hook is there. We don't have now anything else with us. We are into the E1 state minus 2K plus. We are ready for the next action. So once again, when the next action comes, so we come back to, so that once it goes, so we come back to this stage number 1. Stage number 1, that is when the ATP comes. When the ATP comes, right? So it will open up these sodium binding sites. Sodiums will come and land over there. So all seats ready, right? Then the ATPase would act. ATPase would act, and then ATP is broken. We'll let the ADP go, right? ADP is broken, so this would be eliminated from here. ADP is released. We just take the phosphate. Once the phosphate is taken, it goes into the state of that occluded state. Once it is occluded, now it is energized, phosphorylated, ready to open outside. So now it opens outside. Sodiums are released. Still, pump is getting the power. Go into the occluded state. But now, in the next state, it will release the phosphate that is called as the dephosphorylation. Dephosphorylation happens. So now, in the next stage, these potassiums, they will be released. We are back into the original state. And that is when the ATP would come again. And ATP would come again. And here the sodiums, they would be opened. Sodium will connect. And the journey will keep on happening. That's right. That's right. Right. That's right. Because third place is taken by phosphate, so that's why 3 sodiums they go, 2 potassiums they come. So that's that, and this process will keep on working on and on and on forever and ever. It never stops. So this was for today. 5th step, sure. Here it is. Right. In the 5th step, that is when those sodiums they are released outside. Right? They are released outside into the ECF. I'll share the link. I just share the link. I'll share the link. That is where all the PDFs are there. Just a minute. I'll just copy that. Let's search. This is the link where we have kept all those PDFs. All the PDFs are. The email address, there were doubts, right? Crystal clear. Yes, then nice. Okay, show this step. 3, step 4, step 5. Okay. Step 3. Very quickly, we'll go through all the steps. So instead of individually taking step 3 and step 4, whole process again. And I'm changing the color. Yeah, so that you'll understand what are the changes happening. So this is stage 1. This is the alpha protein, and this alpha protein, which is huge one, and it is having all the binding sites. These are the binding sites. Binding sites where the sodium would be binding, potassium would be binding, ATPase would be binding, ATP and phosphate, but at different stages, not all together. Right. So here we start. This is the alpha protein. Right. This is extracellular fluid, intracellular fluid, because this is the cell membrane. Right? This is the cell membrane. At the cell membrane, right, there would be first one. This is our ATP binding site, so that ATP is got. Right. So here it is connected. So now we are changing. We are telling that our state is E1 plus ATP, because this is the beginning stage, starting stage, E1 plus ATP. And the second stage, this is what happens onto the second stage. Right? When the sodiums, their areas, they are open, and sodiums, they come and they get attached. So that is the stage 2. So stage 2, E1 plus ATP was already there. This is the new thing. 3 sodiums, now they are connected onto the stage 3. Now ATP is there, ATPase, right? That ATPase comes into picture. So this ATPase, which is, again, we were having ATPase binding site. So ATPase is connected now with us, and that ATPase will work in-house on ATP. We are connected with ATP also. We have got the ATPase also. So we are telling that ATPase, maar jaake ATP, right? So he hits. When he hits, so then that ATP is broken into ADP and the phosphate. ADP and phosphate. So that phosphate, that is taken back, right? Because we have got a specific site for that. So that phosphate is taken. And this ADP is released because we don't have any attachment with ADP. So ADP is released, right? So this is released. When this happens, what would be the state? The state would be, we have got the 3 sodiums attached. We have got this high energy phosphate, and we now don't have ADP. We don't have any ADP, nothing, but simple 3 sodiums and the phosphate, and we are in good mood. We are energized, right? And this is technically called as the phosphorylated pump. We are energized pump or the activated pump, right? When it happens, so this stage, this is the energized state. This is called as the E2, in which we have got 3 sodium. And obviously the power giving, this is like our battery. Right? So it is that battery is giving us still the power. Further, the whole pump opens into the external environment. This is easier. This is stage 5. In stage 5, because of the presence of this battery, right, this portion opens. It opens, and sodiums, they run and they go with their friends. Right? Sodium, right? Guys. As it happens, so now the situation would be E2 plus our battery, phosphate, and we don't have now 3 sodium because we said bye-bye to those 3 sodiums. When those 3 sodiums, they go, these new 2 sites, they open for potassium, right? This thing occurs parallel, and this entire process, it occurs in fraction of, microseconds. Occurs so fast. Next time we'll be watching that, when we see the whole thing, how it happens, the timings, right? And with what potential, what would be the resting membrane potential, etc. Okay, so coming back to this, those potassium, right? They come and they land and they take their seat. All right, seat beds tied, and the situation is that still we are on E2, highly energized, phosphorylated, our battery is there, and we have loaded 2 passengers, 2 potassiums for the return journey. And now starts our return journey, right? Closed, right? Ready to launch. So this is E2, phosphorylated, passengers loaded, and this is the occluded state. And now we have to open the gates. But this gate will not open. These gates will not open till they are energized. So we say, okay, phosphate, go. As it goes, right, this now opens. This opens into the ICF. So we are back to the stage of E1. And this is called as dephosphorylated. Dephosphorylated. Now we are not charged, right? So dephosphorylated. And these two passengers, the gates are open. So these two passengers, they will jump from their seat. And this phosphate is also released. Yes, it was nice time with me. Bye. And these two passengers, they will also be offloaded. And we are back to stage 1. Our active site for ATP is ready. New ATP comes. As the new ATP comes, it will become E1 plus ATP. Sodium binding sites would open. Sodium would come, right? And then the ATPase will come into picture. That ATPase will break this ATP. ATP would be broken into ADP. ADP would be released. Phosphate, that is picked up, will be going into the occluded state. It will open into the external environment. Sodium, they will leave. Potassium, they will come. Once again, occluded state. Once into that state, this phosphate will go away and it will open, and this potassium they will be released. And that this process, it keeps on going on and on and on and on, non-stop in every cell. Right? So this makes us think that how wonderfully the things have been prepared. How awesome. And this is part of the entire process. So when we say, chalo, let's move the hand, right? Just movement of the hand, a thought which came in the mind, brain sent, chalo, let's send the messages, replace sodium and potassium with some of the other component of the same column. No, this is classically for sodium and potassium. Right? There are other pumps. There are other pumps for calcium. There are other pumps for others. Right? There are separate pumps. So we'll be studying. But this sodium potassium pump is something which keeps on working on and on and on. The most important part. Right? We'll be learning, definitely. Right? We'll be learning about other pumps. So this is what really happens. And that was what was for us for today. Right? So thanks a lot. Thank you so much. And see you day after tomorrow with a very interesting topic. Okay. Thank you and take care. See you soon. Bye-bye. And this file I'm putting just within 1 minute. Thank you.